Okay, today let's work on the hyperbola. Hyperbola, we learned the ellipsis. Ellipsis is from two fixed point right there, and everywhere is the sum of these two line like this. It's the same as this length 2a. That's a ellipse, right? Now hyperbola is from two fixed point. We call it foci. So anywhere this minus this, okay, is the same as this distance 2a right there. That one we call it hyperbola. And even here, this length minus this is 2a too. Actually, you need to go to your point right there. So anywhere on the hyperbola, this blue line right there, right? So any point on this hyperbola, so this two foci, and so this distance minus this, same as 2a. This is a 2a, right? And so that one, when center is 0,0, when focus on the x-axis right there, then the formula is x squares, because on the x-axis side, and then that one here, this distance, this is 2a, one side this a, this is a2, a square, and ellipsis was plus, but hyperbola here minus, and y squares. And then when you draw the any rectangle right there, and this half, we call it b2, b, that's a b squared equals 1. And then ellipsis c squared was longer side, major axis minus axis square, but hyperbola is this, when this is b, this is a, right? Let me draw more accurately. So this is a b, this is a from this rectangle, and this is a c, which is same as this length. C is all the time from center to focus, that's distance is c, and that's this diagonal c same. Okay, this right triangle. So c squared equals a squared plus b squared. So let's practice with a problem. Now find the constant difference for a parabola with a two foci right there, and then point parabola to us 4,0. So let's draw the graph in order to understand. So 5,0, let's say this is 5 right there, then 5,0 there, negative 5,0 here. This says it's foci, I put with x mark right there. And then, and then here, 4,0, that's one of the point on the hyperbola. And then all the time hyperbola graph is around the focus from the passing this point, and like that. This is a vertex right there. And then same, because on the symmetry from the center 0,0, this 4, then this should be negative 4. So this is another vertex right there. And then around this focus, same symmetry on the left and right, like that. So roughly you can draw like that, right? So this length is 2a, which is the difference between these two lengths of this line, right? And then this is a, so a equals 4. And b we don't know here, right? So left for now, let's roughly draw the rectangle right there. This is b, but we don't know. Let's find out. This is c, which is here 5, right? This length is same as this foci. Center to focus, one of the focus distance is 5. That's a c, right? C equals 5. And that also, this diagonal also c, which is a c equals 5 right there. So first, let's find the equation. Equation is all the time focus on the x-axis right there. Then x-axis, you write it minus y-axis. Hyperbola all the time, this is minus, equals 1. And then this is we call it this line 2a, we call it transverse axis. That one is under x-axis, right? So that's why x squared right there. Focus, and then vertex and transverse axis on the x-axis. So x-axis here first, and a was 4, so that's 4 squared, a squared right there. Because formula x squared over a squared, in this case y squared over b squared equals 1, right? So b was, we need to find out, b is c squared equals a squared plus b squared, right? So c is 5, so 5 squared, a was 4, 4 squared plus b squared. Then 25 minus 16, that's 9. B squared is 9, then b is 3 squares, right? This is equation. And then constant difference, which is that's what they're asking, definition of the hyperbola is this distance minus that. It's the same as all the time, this 2a right there. So you can find the distance 2a, which is 2a was 4, right? 4, so constant difference was a. So anywhere that point, so in this case, this one minus that will be 8. Okay. Now let's find the equation of the hyperbola with the vertex and covertex. Vertex means that's a, right? A equals 5. Covertex means this is a b. Because from the center 0, 0, distance is 3, so that's the distance b. So if we draw roughly 5, 0 right here, 5, 0 here, that's the vertex right there, right? And then covertex is 3, 3 right here. So if you draw a rectangle right there, right? So this is 5 vertex, and then this is 3, right? And actually, you know, this one focus on the a little bigger than vertex. So grab something lovely like this, right? Lovely like that. So we're gonna find the equation, vertex on the x-axis, right? On the x-axis, focus on the that side too. So then x squared, right, over, now what? Minus here, y squared over 1. And then this is a squared, right? A is this, right? Vertex, that's 5 squared. And then this is b, that's a 3 squared right there, right? That's the equation. And now here, vertex a, 0. This is also on the x-axis. So let's use 0, 8. Let's change it, vertex. And then focus is also, let's change it, 0, -10. Then this is on the y-axis, right? Then a equals 8, but that's on the vertex y-axis side, right? Then y squared over minus x squared over equals 1. So this is a. Then focus, do you remember the c? That absorb value all the time, that's a 10. So a is a squared. You know, find b, we need to use the formula right there, right? C squared all the time. This right triangle, right? So c squared equals all the time a squared plus b squared. So c squared equals a squared plus b squared. So c was 10, 10 squared equals a was 8, a squared equals b squared. Then 100 minus 64, that's 36. B squared equals 36, b equals plus minus 6. So 6 squared, you can write it equation like that, right? Okay, and then let's say there's a graph of here like this, and this, let's say that's a rectangle right here, and let's say this is a 4, and this is a maybe -6. Then this is a equals 4, and this is a b, right? So b same as this, which is a 6 in this case. C this, but we don't need to know right now. Focus should be on the vertex side. This is the vertex right there. So vertex on the x-axis side, then rewrite the x squared over minus y squared over, right? And equals 1. Here a is 4, then 4 squared, and b is 6 squared. Equation you can find like that right here. Okay, let's find this one like that here, and let's say like this. So this is a -2 and -1. So this is what center, -1, -2, right? So, and then let's draw the box. Rectangle is like this. Okay. Then here center is -1, -2, and then vertex on the y-axis side, right? So you need to write it y first, but vertex center is not 0, 0 anymore. So but square minus something square equals 1, and because on the y-axis side you started right first, and this is a center, then y plus 1 square after you, right? Oh no, this is a -2, then this should be this one y is -2, y plus 2 square, x plus -1, then plus 1 square, right? And then this is a, right? From the center to the vertex. That's a 2, right? 2 squares. And then this is a, which is here -1 to 0, that's 1, so 1 square. That's the equation of this hyperbola. Now let's find the center, vertices, vertices, foci, and asymptote. So this is a coefficient is different, and then the sign is one positive, one negative. Then this is a hyperbola. Then make one, you know, to find a and b. So divide by everywhere 100. So 100 and 100. That means divided by 1 and 4, then that's 25. So y squared is over 25 minus x squared is over 100 equals 1. So a equals 5, b equals 10, right? So if we draw the graph, that's lovely. Then 0, that's y-axis, right? So vertex on the y-axis, so 5 and -5. And then b is on the x-axis right there, and 10. So if we draw the rectangle, it's like this, right? And this is center. You know, to draw the graph better all the time, vertex, you write it, and then draw diagonal passing through this center, and then diagonal of this rectangle. You draw that here, and then lovely draw the graph all the time from the vertex. This x line, we call it asymptote. Asymptote from here, you're approaching that, but never touch or cross. Just keep approaching. That's asymptote means, right? So like this and like this. You can draw a graph like that, right? So we want to find out first center. Center was 0, 0, right? Right there, 0, 0. Center is 0, 0. And vertex was from A was 5 on the y side, right? So plus minus 5 on the y. So 0, 5 and 0, -5 was vertex right there, right? And then co-vertex and B, right? B was x side, and so x side 10. So you're going to add plus minus 10 here, and so 10, 0 and -10, 0, right? And then foci. You know, to find foci, you need to find C. C squared equals A squared plus B squared, right? Formula. Because C is all the time triangle right there, right? This is C, right? Then A was 5, so 5 squared, 25, and B is 10, 10 squared, 1, 125. C squared is 125. C equals plus minus square root 125. That's 25 times 5. 25 is 5. Square root 25 is 5. For 5 root 2, 5. That's under all the time. Set the foci under vertex side, right? So here you're gonna add y value there, plus minus 5 root 5. So foci is 0, plus minus 5 root 5, right? And asymptotes is you know, like a kind of a little bit different. So from here, you one after you, this is 1, then you make 1 0 and sub y. So sub y, you move this one the other side first, y squared over 25 equals x squared over 100, right? So 25, you move the other side, division, multiplication, so y squared equals 25 over 100 x squared, right? This is 1/4, right? And square root both sides, square root plus minus, right? Y equals 1/4, square root is 1/2, so plus 1/2 x. So this line equation plus 1/2 x, this is a minus 1/2 x. Okay, so you can find it that way. So now without drawing the graph, maybe we can draw the graph later. Let's find out center, vertices, covertices, and foci. So let's do that first. Here, center first. Center all the time making this one 0, 2, comma, this making 0, y plus 3, 0, minus 3, that's the center, right? And then find out vertex, vertex all the time, first one, plus 1. So A is plus minus 4, A is 4 here. And this is B, right? B is plus minus 7. So you're gonna add this one to x value right here because this is vertex is on the x-axis. So plus minus 4 here. Then you add 4 here, 6 comma minus 3. Y value same, right? And then you minus 4. Then 2 minus 4 is minus 2 comma minus 3. And then covertices. This is a plus minus B is plus minus 7. That's put y value there. So you need to keep x value as it is, but you need to put y value right there, right? So x value 2 same, minus 3 plus 7, that's a 4, and then 2 comma minus 3 minus 7 minus 10, right? You know, find foci. Now you find c squared. C squared equals a squared plus b squared. 16 plus 49, 50, 65, 65, right? 65, 65 is divisible by 5, and that's 1, 5, 15, 13, 13 and 5, so not factor, not perfect square, any perfect square there. Then that means C equals plus minus square root 65, right? That you're gonna add where? On the vertices side. So you need to add on the axis, plus minus square root of 65 here. Keep it y value. So foci is 2 plus minus square root of 65, comma, y value same, minus 3, right? So, and then finding asymptotes, that one making 0. Asymptotes are a little bit hard. Making 0, sub y. So sub y, I'm gonna move y the other side. So x minus 2 squared over 16 and equals y plus 3 squared over 49. I move this one this side. And you know sub y, I move this one the other side. 49 over 16, right? And then square roots and square roots plus minus. 49 can go out as 7, 4 go out as 4, and here x minus 2, right? Y plus 3. And you know to sub y, and then plus minus 7 over 4, x minus 2 plus 3. You can simplify, but I'm going to take it as it is. Okay? Just like that. And then drawing hyperbola, let's try, practice one more time. All the time center first. Center is 2 comma negative 3, right? So x equals 2, y negative 3. Here center. And then A is x value plus minus 4. So you're going to move 1, 2, 3, 4 there. And 1, 2, 3, 4 there. That's the vertex, right? And then covertex B is a plus minus 7. So from here, move 7. So that's a 4 here. And move 7 down here, right? So that's a 10, negative 10, right? So that's a covertex. You draw the box like that, right? Rectangle. Draw rectangular. And then from the center, this is vertex, right? So draw asymptote right there, right? And then now from the vertex, draw approaching asymptote. From the vertex, approach asymptote right here. That's a graph of the hyperbola.